Alright, let's look at a few example problems, the kind of thing you're going to see. First, you're going to be asked to state the most specific name for a figure. So we look at this and we know the options that we're looking at is this is either going to be a trapezoid or a kite. For a trapezoid, we need to know that a pair of opposite sides is parallel. We don't have any of that information here, but we do see that consecutive sides are congruent and that no opposite sides are congruent. So we can very safely say that number one would be a kite. Literally as simple as that. Alright, for number two, we notice we have one pair of sides that is parallel, so that means we're looking at a trapezoid. And we also know that the legs of this trapezoid are congruent, so we would say this is an isosceles trapezoid. And that is very seriously all you're doing there, just using the properties of those figures to identify them. Alright, next thing you'll have to do is find the length of the mid-segment of a trapezoid. And if you'll remember, the mid-segment is equal to 1/2 the sum of the bases. So base 1 plus base 2. It really doesn't matter which base you call which. It'll work both ways. So if I want to find my mid-segment, all I have to do is plug in the length of those bases. Base 1, I would substitute in a 24 there, plus base 2 would be a 16. And now all that's left is some simplifying. So I can see that 24 plus 16, that's going to be 40. So my mid-segment is 1/2 of 40, so that I know the length of my mid-segment is going to be 20, and since we're not given any units, that's the best we can say. So again, I'm just using my formula that the mid-segment is 1/2 base 1 plus base 2. Alright, our final type of problem is going to look like this. You're going to be asked to find the length of the indicated base for a trapezoid. So what you'll need to do on this one is again set up your mid-segment formula. So we know the mid-segment is 1/2 base 1 plus base 2. And now we substitute into this equation what we know. The mid-segment has a length of 13.2. Base 1 we'll call RU, so we don't know what that is. Base 2 would be 6.8. And now I can distribute all of that. So I get 1/2 x plus 3.4. Now I can subtract 3.4 from both sides. And that is going to give me 9.8 equals 1/2 x. So now to get rid of that 1/2, I'm going to multiply by 2. And when I multiply by 2, I'll find that x equals, let's see, times 2, that'd be 18. That would be 19.6. And again, I have no units, so I can't say anything more specific than that. So the length of RU, if I want to get super specific here, would be 19.6, just like that.